For decades, we've been the ones designing AI algorithms, right? We've been the architects. But what happens when the AI starts being the architect? We're talking about a huge shift here, not just for AI, but for how we discover things, period.
Seriously, just let that sink in for a second. This isn't just about an AI solving a problem we hand it. No, this is about an AI finding totally new ways to solve problems. We're talking about methods that a human might never, ever think of. They might seem completely alien to us.
Okay, so to really get why this is such a game changer, we kind of have to look at how things have always been done. I like to call it the craftsman's dilemma.
Imagine the top AI researchers out there. Think of them like master craftspeople, you know? They have amazing intuition, incredible expertise. But for the longest time, they've been building these super complex algorithms, mostly by hand. It's a process that's, well, it's brilliant for sure, but as you're about to see, it has some serious limitations.
So yeah, this is basically the old way in a nutshell. It's this slow, really tedious loop. You start with a decent algorithm, an expert has a eureka moment, they code up the new idea, they test it, they look at the results, and then they do it all over again, and again. And look, this system has given us some incredible stuff, but it's completely powered by human brain power, and, well, a lot of coffee.
And that's the real problem, right? This whole human-driven thing is a massive bottleneck. We're stuck inside the box of our own imagination and biases. So what if the best solutions, the truly optimal ones, are kind of weird? So counterintuitive that no human would ever even think to try them in the first place?
So, the big question is, how do you break out of that loop? How do you get outside the box? Well, some researchers at Google DeepMind came up with a pretty wild answer. You get an AI to design another AI.
And this is it. It's called Alpha Evolve. The core idea is just so cool and elegant. It takes an algorithm's source code and treats it like DNA, like a genome. Then it uses a large language model to evolve that code, generation after generation, making it better and better. It's literally Darwin's theory of evolution, but for computer code.
Now this is the really key part. This isn't just random changes. The LLM isn't just flipping a 0 to a 1. It acts like an intelligent genetic operator. It's rewriting whole sections of logic, trying out new control flows, stuff like that. This lets it search to this massive, massive space of possible algorithms that a person could never hope to explore on their own.
Okay, so check out the new process. Instead of one algorithm, you start with a whole population of them. The system finds the fittest one, the best performer, and hands its code over to the LLM. The LLM then mutates it, creating a new child version. That new version gets tested automatically. If it's better, awesome, it gets added to the population. And you just repeat that thousands and thousands of times. What you get is a powerful, totally automated engine for discovery.
Of course, an idea this huge needs some serious proof, right? So for the first big test, the researchers basically gave Alpha Evolve a challenge. Hey, can you take one of the most important algorithms for solving complex games and make it even better?
The algorithm they targeted is from a family called counterfactual regret minimization, or CFR for short. Now, this is basically the gold standard for teaching an AI to play games with hidden information, like poker. The way it works, in simple terms, is that the AI plays over and over, and after each round, it looks back and kind of thinks, man, I really regret not making that move instead, and then it uses that regret to adjust its strategy for the next time.
And what happened was just fascinating. Alpha Evolved spit out a brand new algorithm they called VAD-CFR, and it was filled with these really weird but super effective ideas. For example, get this, it decided to just wait. For the first 500 iterations, it completely ignored everything it was learning before it even started to build its main strategy. That's like a poker player deciding to learn absolutely nothing from their first few hundred hands. It's so counterintuitive, a human designer probably never would have tried it, but it worked like a charm.
And here's the hard data. This table shows something called exploitability, which is basically just a measure of how easy it is for a perfect opponent to beat the AI. So lower is way, way better. Now just look at three-player Leduc poker. The new evolved AI, VAD-CFR, is an entire order of magnitude harder to beat than the best version designed by humans. The numbers here really speak for themselves.
Okay, but was that just the lucky shot? A one-time thing? To prove that this whole framework was the real deal, the team pointed it at a completely different type of algorithm.
This time, the target was something called Policy Space Response Oracles. Let's just call it PSRO.
You can think of this one less like a player and more like a coach algorithm. Instead of teaching a single AI one strategy, it's actually managing a whole team of AIs, all with different styles. The coach's whole job is to figure out the best countermove to whatever the team is currently doing, which makes the whole group tougher and tougher over time.
And what do you know? The discoveries were all about being dynamic and adaptive. The new algorithm it came up with, Shorupsaro, learned how to create this cool hybrid style. It makes safe, stable learning with really aggressive, opportunistic moves. But what's even more impressive is that it figured out how to automate one of the hardest things in AI design: the trade-off between exploring new ideas and just exploiting what you already know works. That's a dial that human designers usually have to tune by hand, and this thing just figured it out on its own.
And yep, the data tells the exact same story again. Lower is better, remember? In a really complex 4-player poker game, the evolved AI found a strategy that was just way tougher to beat than the human-designed one. So this proved it wasn't a fluke. The framework really is general. It can find better algorithms in totally different kinds of systems.
So, what's the big takeaway here? Let's zoom out for a second. We're not just talking about better poker-playing AIs. This could be a whole new way of doing science, a new paradigm for discovery itself.
This is the real shift. We're moving from a world that's totally reliant on human intuition to one that uses automated evolution. We're going from being stuck with the ideas we can come up with on our own to exploring this gigantic search space of possibilities to find those weirder, non-intuitive solutions that just flat out work better.
And look, it's really important to get this part right. The point of this isn't to replace human scientists. It's to give them a brand new, incredibly powerful tool. The human still sets the goals, they define the playground, and they have to make sense of the results. The AI just becomes this tireless, unbelievably creative partner that can go down paths we never would have even known existed.
Which, of course, leaves us with one final and pretty mind-blowing question. We've seen it work for games, sure, but where else could this go? Could an AI discover new algorithms to make global supply chains more efficient? Or find new methods for discovering life-saving drugs? Could it even help us find new, fundamental laws of physics? We are heading into a future where AI doesn't just give us the answers we're looking for. It helps us find completely new questions to ask.